Imagine a universe where every choice you've ever made and every choice you didn't exists somewhere else right now in another reality. A place where you took the path you hesitated to walk, said the words you never spoke, or lived a life you only dreamed of. This isn't science fiction. It's a mind-bending possibility suggested by quantum physics. At the heart of this radical idea lies the concept of the multiverse, a theory proposing that our universe may be just one among countless others, each shaped by different events and outcomes. According to some interpretations of quantum mechanics, every time a quantum event occurs, the universe splits, creating a new branch, a new reality where every possibility becomes real. In other words, somewhere out there, a version of you made that choice you thought you'd never make, and it's living a completely different life. This idea challenges everything we think we know about existence, identity, and the meaning of choice. It raises staggering questions. Are there infinite versions of ourselves living out every potential decision? Can these realities somehow overlap or influence one another? And what does it mean for free will, destiny, and the nature of reality itself? In this video, we'll explore the quantum theories behind parallel realities, from Schrödinger's famous cat to Hugh Everett's revolutionary many worlds interpretation. We'll journey through cosmic multiverses, quantum entanglement, and even thought experiments that push the boundaries of life and death. By the end, you may never look at reality the same way again. Strap in, because the universe is far stranger and more magnificent than your mind can imagine, and what you think of as reality might just be one note in an infinite symphony of worlds. Welcome to Self-Unlocked, the space where cutting-edge science meets ancient wisdom to help you unlock your true potential. Stay curious, stay conscious, because your journey to self-mastery starts right here. To understand the astonishing concept of parallel realities, we must first take a journey into the world of the very small, the realm of quantum mechanics. This is the science that explores the behavior of particles so tiny that they defy our everyday experience. Electrons, photons, and atoms don't follow the same rules as the objects we see and touch every day. In fact, the microscopic world behaves in ways so strange that it has baffled even the greatest minds in physics for over a century. The story begins in the early 1900s, a time when classical physics, Newton's laws, Maxwell's equations, seemed to explain nearly everything about the universe. Planets followed predictable orbits, light could be understood as a wave, and matter seemed solid and continuous. But new experiments started revealing cracks in this elegant framework. Physicists were observing phenomena that could not be explained by classical physics. One of the first cracks appeared with blackbody radiation. Classical theories predicted that hot objects would emit infinite energy as they heated up, a paradox now known as the ultraviolet catastrophe. The solution came from Max Planck, who proposed that energy is not continuous but comes in discrete packets called quanta. This was the birth of quantum theory, a radical idea that energy and matter at tiny scales behave differently than we perceive in our daily lives. Not long after, Albert Einstein took the idea further. In 1905, he explained the photoelectric effect, showing that light itself is made of particles later called photons. Suddenly, light was both a wave and a particle, and reality was no longer as straightforward as it seemed. Physicists began to realize that the microscopic world doesn't conform to classical expectations. Particles can exist in multiple states, interfere with themselves, and act in ways that seem almost magical. By the 1920s, a new generation of physicists, Niels Bohr, Werner Heisenberg, Erwin Schrödinger, and Paul Dirac, began formalizing this strange reality. Bohr introduced the complementarity principle, suggesting that particles can behave as waves or as particles, depending on how we observe them. Heisenberg formulated the uncertainty principle, which revealed a fundamental limit to what we can know. The more precisely we know a particle's position, the less precisely we can know its momentum. Reality, it seemed, is inherently probabilistic. At the center of this revolution was Erwin Schrödinger, who developed the wave equation. This equation describes a particle not as a single point but as a wave of probabilities, existing in multiple states simultaneously. The particle's exact state is not determined until it is measured, a concept known as superposition. Schrödinger famously illustrated this with his thought experiment: a cat in a sealed box that is simultaneously alive and dead until observed. These discoveries shattered the deterministic worldview of classical physics. In the quantum realm, nothing is fixed. Everything is a possibility, a probability waiting to become reality. This probabilistic nature of the universe laid the foundation for the idea of parallel realities. If a particle can exist in multiple states at once, could it be that each possibility corresponds to a different version of reality? Quantum mechanics also introduced another mind-boggling phenomenon: entanglement. When particles become entangled, their states are linked no matter how far apart they are. A change in one particle instantaneously affects its partner, even across vast distances. Einstein called this spooky action at a distance, and it hinted at a deeper, hidden connectivity in the universe, a glimpse of the threads that might connect parallel worlds. But quantum mechanics wasn't just theoretical. Experiments consistently confirmed its predictions. The famous double-slit experiment showed that particles like electrons create interference patterns, behaving as waves when unobserved, yet as particles when measured. This means that reality itself depends on observation, blurring the line between the observer and the observed. By the mid-20th century, quantum mechanics had become a fully fledged theory, explaining phenomena from atomic structure to semiconductor technology, the foundation of modern electronics. Yet, despite its success, it left one haunting question unanswered. What exactly happens when a quantum system is measured? How does a wave of probabilities collapse into a single reality? Some physicists offered an explanation. Perhaps there is no collapse at all. Perhaps, instead of probabilities collapsing into one reality, all possible outcomes occur, but in separate, branching universes. This radical idea, proposed by Hugh Everett decades later, would become the foundation for the many worlds interpretation, but its roots lie here, in the strange and beautiful mathematics of quantum mechanics. Quantum mechanics is more than just equations and experiments. It is a revolution in how we understand existence. It tells us that at the smallest scales, the universe is not deterministic, not fixed, not singular. Instead, it is a cloud of possibilities, an intricate dance of probabilities that challenge our most basic assumptions about reality. So, as we explore the concept of parallel realities, remember this: the quantum world reveals a universe far stranger than we could have imagined. A universe where reality is fluid, probabilities are real, and every choice or event might lead to a branching path. A different world, waiting to exist. Quantum mechanics doesn't just describe the building blocks of matter. It opens the door to a cosmic vision where the universe is infinite, layered, and full of untold possibilities. And it is from this strange and wondrous world that the idea of parallel realities was born. If you thought the quantum world couldn't get any stranger, welcome to Schrödinger's cat, perhaps the most famous thought experiment in the history of physics. This seemingly simple scenario reveals one of the most mind-bending ideas in quantum mechanics. Superposition, the concept that a particle or even a system can exist in multiple states at the same time until it is observed. In 1935, Erwin Schrödinger, one of the founders of quantum mechanics, proposed a hypothetical experiment to illustrate a problem in the prevailing interpretation of quantum theory. Imagine a cat sealed inside a completely opaque box. Alongside the cat is a vial of poison that will be released depending on a quantum event, say a radioactive atom decaying. If the atom decays, the poison is released and the cat dies. If it does not decay, the cat lives. Here's the mind-bending part. Quantum mechanics suggests that until the box is opened and observed, the atom exists in a superposition of decayed and undecayed states. Because the cat's fate is tied to the atom, the cat itself is theoretically both alive and dead simultaneously. Only upon observation does the superposition collapse into a single outcome, a living cat or a dead cat. This paradox wasn't meant to suggest that actual cats are literally both alive and dead in a practical sense. Schrödinger's goal was to show that the standard quantum interpretation, the Copenhagen interpretation, championed by Niels Bohr, leads to absurd conclusions when applied to everyday objects. In other words, quantum rules work perfectly at the level of atoms and electrons, but they seem bizarre, even impossible, when scaled up to macroscopic objects like cats. Yet, despite its absurdity, Schrödinger's thought experiment reveals something fundamental about the quantum world. Until measured, systems exist in multiple possible states simultaneously. In other words, reality is not fixed but a web of probabilities, a spectrum of potentialities waiting to manifest. Superposition is at the heart of quantum strangeness. Consider the implications. In classical physics, a coin is either heads or tails, a light switch is either on or off. In the quantum world, however, particles can exist in both states at once. Only when measured does the outcome choose a particular state. This challenges our very intuition about what it means for something to exist. Is reality absolute, or is it conditional, dependent on observation? Physicists have conducted experiments to demonstrate superposition, most famously in double-slit experiments. When individual electrons pass through a pair of slits, they form an interference pattern, behavior characteristic of waves. Yet, if we attempt to observe which slit the electron passes through, the interference disappears, and the electron behaves like a particle. Here, the act of observation forces a single outcome from a range of possibilities, a real-world analog to Schrödinger's cat. Superposition also underpins some of the most revolutionary technologies of the 21st century. Quantum computing, for example, relies on quantum bits or qubits, which can exist in multiple states simultaneously. Unlike classical bits that are either 0 or 1, qubits can be both 0 and 1 at once, enabling computations that would take classical computers millennia to solve. In essence, the technology of the future depends on harnessing the very strangeness Schrödinger highlighted nearly a century ago. But superposition raises profound philosophical questions. If a system can exist in multiple states at once, what is the nature of reality itself? Is there a true state, or are all possible states equally real until measured? This is where interpretations diverge. The Copenhagen interpretation suggests that reality only becomes definite when observed. But the many worlds interpretation, proposed by Hugh Everett in 1957, offers a radically different view. Every possible outcome actually occurs, but in a separate branching universe. According to many worlds, the cat is both alive and dead, but in different worlds. In one branch, you open the box to find a living cat. In another, a dead cat. Each outcome is equally real, existing in parallel realities that do not interfere with each other. Superposition, in this view, is not a probability that collapses, it's a multiverse in action, with every quantum possibility realized somewhere. The philosophical implications are staggering. If superposition applies not just to cats but to people, choices, and events, then every decision we make may spawn multiple realities, each reflecting a different path. Could there be a universe where you chose a different career, a different friend, or even a different life entirely? Schrödinger's cat may be the gateway to understanding the profound possibilities of a multiverse. Superposition also challenges our perception of time and causality. In a world where multiple outcomes coexist, the notion of a single, linear timeline becomes uncertain. The universe may be a vast branching tree, with every event creating new branches and new worlds, all unfolding simultaneously. Schrödinger's cat is more than a paradox. It is a lens through which we glimpse the strangeness, complexity, and infinite potential of reality. Schrödinger's experiment does more than highlight the quirks of quantum mechanics. It forces us to question the very foundation of existence. What does it mean to be alive or dead? To exist or not exist? And could it be that reality is not a single, absolute state, but a multitude of coexisting possibilities, each waiting to be experienced? Superposition is not just a scientific curiosity. It is a profound statement about the universe. It tells us that the quantum world is fluid, probabilistic, and infinitely rich. Every particle, every atom, and every choice may exist in multiple states at once, hinting at realities far beyond our ordinary perception. As we continue our journey into the world of parallel realities, Schrödinger's cat reminds us that the universe is not as simple as it seems. Beneath the surface of what we observe lies a cosmic dance of possibilities, a hidden realm where multiple outcomes coexist, and where reality itself is more mysterious and more beautiful than we can imagine. By the 1950s, quantum mechanics had firmly established itself as one of the most successful theories in physics. Schrödinger's cat, Heisenberg's uncertainty principle, and the double-slit experiment had revealed a universe far stranger than our everyday experience. Yet a nagging question remained: what actually happens when a quantum system is measured? When a particle is in superposition, existing in multiple states at once, why do we only observe one outcome? The prevailing explanation at the time was the Copenhagen interpretation, developed by Niels Bohr and Werner Heisenberg. According to this view, a quantum system exists in multiple states, but observation collapses it into a single reality. In other words, reality depends on the act of observation. While effective for calculations, this interpretation raised philosophical concerns. What constitutes an observer, and why should consciousness affect reality? Enter Hugh Everett III, a young American physicist who, in 1957, proposed a revolutionary idea that would challenge conventional thinking: the many-worlds interpretation, MWI. Rather than forcing a wave function to collapse into a single outcome, Everett suggested that all possible outcomes of a quantum event actually occur, each in its own separate, equally real universe. Imagine you flip a quantum coin. In our observable reality, we see either heads or tails. But in Everett's framework, the universe splits into two. In one branch, the coin lands heads. In the other, tails. Both outcomes exist, both are real, but they are in separate, non-communicating worlds. In essence, every quantum decision, every choice, every event creates a branching universe. This idea, though elegant, was initially controversial. To many physicists, it seemed extravagant, almost absurd. Why postulate an infinite number of unseen universes? Critics asked. Everett, however, argued that it was the simplest solution mathematically, removing the need for an observer-dependent collapse and providing a deterministic, fully quantum description of reality. In his view, the universe never collapses. It only branches endlessly, creating an ever-growing tree of possibilities. The implications of the many worlds interpretation are staggering. If every possible outcome exists, then every decision we make generates new realities. There could be universes where you chose a different career, where historical events unfolded differently, or even where life on Earth never existed. In this view, reality is not a single timeline but a vast, branching multiverse, with an infinite number of parallel worlds coexisting simultaneously. Everett's theory also offers a new perspective on Schrödinger's cat. In the Copenhagen interpretation, the cat's superposition collapses upon observation. In many worlds, the cat is both alive and dead, but in different worlds. When you open the box, you find a living cat in one branch and a dead cat in another. Both outcomes are equally real, yet you only perceive the version in your branch. This simple thought experiment suddenly becomes a literal illustration of a multiverse in action. Many worlds also reshapes our understanding of probability. In traditional quantum mechanics, the wave function gives the probability of a particular outcome. But in Everett's universe, all outcomes occur. So probability reflects the distribution of observers across branches rather than the likelihood of an event happening. Your experience of one outcome is just one of countless perspectives in a vast cosmic ensemble. Over time, MWI has gained more acceptance, especially among physicists who study quantum computing, decoherence, and cosmology. Quantum computing, for example, exploits superposition to perform multiple calculations simultaneously. Some interpretations suggest that these computations are effectively being carried out across multiple branches of reality, with the results converging in the branch we observe. The philosophical implications are equally profound. If multiple versions of ourselves exist in parallel realities, what does that mean for identity and free will? Is there a true you, or are we all just one branch among infinite selves? In some universes, every choice you've ever imagined has been made. Somewhere, a version of you is living the life you fantasized about, making decisions you will never make. Many worlds also challenges our notions of causality and destiny. If all outcomes exist, then there is no single predetermined future. Every possibility unfolds somewhere in the multiverse, and history is not a linear chain of events but a tree with infinitely branching limbs. This perspective transforms our understanding of the universe from a fixed, deterministic machine into a living, dynamic cosmos filled with infinite possibilities. Despite its elegance, the theory still faces challenges. How can we test the existence of other branches if they do not interact with our own? Can we ever detect or communicate with parallel worlds? While these questions remain unanswered, experiments in quantum decoherence provide indirect support. Decoherence explains how superpositions effectively split into separate, non-interacting branches at macroscopic scales, giving a scientific framework for many worlds. Hugh Everett's many worlds interpretation forces us to rethink reality itself. It invites us to imagine a universe far larger, stranger, and more beautiful than we ever dreamed. Every quantum event, every choice, every possibility is not just a probability. It is a reality that exists somewhere, branching endlessly into infinity. As we continue our exploration of parallel realities, remember this. The strange quantum behaviors that once seemed absurd are now the doorway to understanding a multiverse teeming with life, events, and versions of ourselves. Everett's theory may not answer all the questions, but it reveals a universe far richer and more wondrous than we ever imagined. And it all begins at the tiniest scales of existence, where the rules of classical physics no longer apply. If Hugh Everett's many worlds interpretation revealed that all possible outcomes occur in separate realities, then quantum entanglement might be the invisible thread connecting these worlds in ways we are only beginning to understand. Entanglement is one of the most fascinating and mysterious phenomena in quantum mechanics. It challenges not only our intuition but also our understanding of space, time, and the very nature of reality. Quantum entanglement occurs when two particles interact in such a way that their states become linked, no matter how far apart they travel. Change the spin of one particle, and the other particle instantly reflects that change, even if it is light years away. Albert Einstein famously derided this as spooky action at a distance, because it seemed to violate the universal speed limit set by the speed of light. How could one particle know what the other was doing instantly? Experiments over the past century have repeatedly confirmed entanglement. The results are undeniable. Entangled particles are correlated in ways that cannot be explained by classical physics. These connections are real, measurable, and reproducible. And while no information is transmitted faster than light, The instant coordination between entangled particles suggests a hidden web of quantum reality underlying the universe. Entanglement is intimately connected to superposition. A pair of entangled particles exists in multiple states simultaneously, forming a shared wave function that only resolves upon measurement. The moment we measure one particle, the entire system collapses into a definite state. But in the context of many worlds, something extraordinary happens. The wave function never truly collapses. Instead, each possible outcome occurs in a separate branch, meaning the entangled particles take all possible correlated states, but in parallel realities. This opens a tantalizing possibility. If entanglement links particles across space in our universe, could it also hint at interactions between parallel realities? Some physicists and theorists speculate that entangled states are like quantum threads, invisible connections that extend not just across distance, but across the multiverse itself. In other words, entanglement might be a glimpse into a higher dimensional reality where multiple worlds coexist and influence each other subtly. Consider this: if two entangled particles can instantaneously affect each other across vast distances, then perhaps branches of the multiverse are not entirely isolated. Could faint echoes of other realities influence ours in subtle, measurable ways? Some researchers suggest that this might explain quantum randomness or even rare, seemingly improbable events in our universe. While this idea is highly speculative, it highlights how quantum entanglement challenges our understanding of separateness, individuality, and causality. Entanglement has practical applications as well, giving rise to technologies that border on science fiction. Quantum cryptography, for instance, relies on the correlations between entangled particles to create secure communication channels that are theoretically unhackable. Quantum teleportation uses entanglement to transfer the state of a particle from one location to another without physically moving it. These breakthroughs show that the threads of quantum reality are not just theoretical. They can be harnessed, manipulated, and tested. Yet, the philosophical implications are equally staggering. Entanglement suggests that nothing in the universe is truly isolated. Every particle is connected to others, forming an intricate web of cause and effect that extends across space, and perhaps across multiple realities. This challenges the classical notion of individuality and separateness, implying that the cosmos is fundamentally interconnected, and that our universe may be just one node in a vast, entangled multiversal network. Some speculative thinkers even propose that entanglement could explain phenomena that appear improbable or mysterious in our world. Could déjà vu, intuition, or unexplained coincidences be subtle echoes of parallel realities brushing against our own? While mainstream science doesn't claim this as fact, the idea underscores the strange, almost poetic implications of entanglement. The universe may be far more intertwined than we can perceive. Entanglement also deepens our understanding of the observer's role in quantum mechanics. In traditional Copenhagen interpretation, measurement collapses the wave function into a definite outcome. But in many worlds, the observer becomes part of the branching process. When you measure an entangled particle, both outcomes occur in separate realities, and you, too, branch along with the results. Your consciousness is no longer a passive witness. It is woven into the fabric of the multiverse, experiencing one branch among countless others. This leads to a profound realization. The universe may be a tapestry of interconnected possibilities, where superposition and entanglement create an intricate network of outcomes, each as real as the one we experience. Our reality is not a singular, isolated timeline, but a dynamic, entangled structure, constantly branching and intertwining with infinite others. Entanglement reminds us that the quantum world is not only strange, it is beautifully interconnected. It suggests a cosmos in which distance, time, and even separate realities are more fluid than we imagined. The threads of the universe may stretch beyond our perception, linking events, particles, and perhaps even worlds across the multiverse. As we explore the mysteries of parallel realities, Entanglement serves as both a guide and a warning. It teaches us that the universe is more than what we see. It is a complex, interconnected web of possibilities, a symphony of quantum states that may extend across infinite realities. Understanding entanglement is not just a scientific endeavor. It is a journey into the hidden architecture of existence itself, revealing the threads that connect us to worlds we cannot yet observe. Quantum entanglement, in combination with superposition and many worlds, paints a picture of reality that is simultaneously scientific and profoundly poetic. The universe is not a fixed stage but a living, branching, and entangled cosmos, where every choice, every particle, and every possibility is part of an infinite, interconnected multiverse. If quantum mechanics reveals a universe where possibilities branch endlessly at the smallest scales, then cosmology expands this idea to the largest scales imaginable. The notion of a cosmological multiverse suggests that our universe, everything we see, measure, and experience, might be just one of countless universes in a far vaster cosmic landscape. This is a reality so immense it challenges the imagination and forces us to reconsider what it truly means to exist. The story begins with the Big Bang, the event that gave birth to our universe roughly 13.8 billion years ago. According to standard cosmology, the universe expanded from a singular, unimaginably dense point. But what if this wasn't a unique event? What if the Big Bang is just one of many, each creating its own universe with its own laws of physics, constants, and dimensions? This is the foundation of the cosmological multiverse theory. One of the most compelling frameworks for understanding the multiverse comes from inflationary cosmology. In the 1980s, physicist Alan Guth proposed that the early universe underwent a period of rapid exponential expansion, known as cosmic inflation. This inflation explains why the universe appears uniform and isotropic on large scales. However, some models suggest that inflation never completely stops. Instead, pockets of space can stop inflating at different times, producing bubble universes that expand independently. Our universe could be just one of these bubbles in an infinite cosmic foam. Each bubble universe could have different properties. Some might have different physical constants, such as the strength of gravity or the speed of light. Others might have completely different dimensions or forms of matter. In some universes, life as we know it could be impossible, while in others it could flourish in unimaginable ways. In this framework, the multiverse is not a single, uniform entity. It is diverse, vast, and possibly infinite. The cosmological multiverse concept also finds support in string theory, a leading candidate for a theory of everything. String theory predicts an enormous landscape of possible solutions, each corresponding to a different universe with its own unique laws of physics. This string landscape implies a near-infinite number of potential universes, each existing in its own corner of reality. If true, the multiverse is not merely hypothetical, it is a natural consequence of the laws that govern our cosmos. The idea of multiple universes also provides a potential solution to one of the most puzzling questions in physics: the fine-tuning problem. Our universe appears exquisitely calibrated for life. The values of fundamental constants are set within a narrow range that allows stars, planets, and chemistry to exist. Why is our universe so perfectly suited for life? In a multiverse, the answer becomes less mysterious. If countless universes exist with varying properties, it is inevitable that some would randomly have the right conditions for life. We happen to live in one of those universes, not because it was destined, but because only such a universe could support observers like us. Yet the cosmological multiverse is more than a theoretical construct. It has profound philosophical implications. If multiple universes exist, then our reality is not unique or absolute. Every cosmic event, every quantum fluctuation, Every branching possibility in our universe could give rise to other realities elsewhere. The multiverse is a vast, interconnected web of existence, where our universe is a single thread in an infinite tapestry. Some theorists even speculate that the multiverse might offer ways for parallel universes to interact, albeit subtly. Certain models of quantum cosmology suggest that entanglement and quantum fluctuations could, in principle, link different universes, creating faint echoes of other realities in ours. These ideas remain speculative, but they hint at a profound unity underlying the diversity of existence. The concept of cosmological multiverses also resonates with philosophical and existential questions. If our universe is one of countless others, what does that mean for our sense of significance and purpose? Are we alone, or are there civilizations thriving in entirely different universes? Could our reality be just one expression of a deeper, more complex cosmic order? From a human perspective, the multiverse can be both humbling and awe-inspiring. It challenges the notion that the cosmos revolves around us or our universe. Instead, it suggests a cosmos of extraordinary magnitude, filled with infinite possibilities, each universe a stage for phenomena as strange, beautiful, and mysterious as our own. In connecting cosmology with quantum mechanics, the multiverse concept bridges the very small with the very large. Just as quantum superposition and entanglement reveal a world of probabilities and branching outcomes at the microscopic level, cosmology extends this branching structure to the universe itself. Our cosmos, it seems, may be just one bubble among countless others, all part of an infinite cosmic ocean, each universe evolving independently yet governed by the same fundamental principles of physics. As we explore the multiverse, it becomes clear that reality is far stranger and richer than we could have imagined. From the tiniest particle to the largest galaxy, from the probabilities of quantum mechanics to the bubbles of inflationary cosmology, the universe is a complex, branching, and interwoven tapestry of possibilities. And in this vast multiverse, every possibility, every choice, and every quantum event may give rise to a new universe, a new reality, a new world. The cosmological multiverse pushes us to reconsider not only the nature of existence but also our place in the grand cosmic order. It invites us to imagine a reality that is not singular but infinite, not fixed but constantly branching, not limited but endlessly expansive. The universe we inhabit is extraordinary, but it may be just one of countless universes, each waiting to reveal its secrets. If the many worlds interpretation and cosmological multiverses have already stretched your imagination, then the quantum suicide experiment will push it even further. This thought experiment, first proposed by physicists Hugh Everett and later refined by Max Tegmark, takes the ideas of quantum branching and superposition into the realm of consciousness, asking a disturbing yet fascinating question. What happens to the observer in a universe where all possible outcomes occur? The setup is deceptively simple but morally unsettling. Imagine a physicist sitting in a sealed room with a quantum device, a device tied to a deadly outcome based on a quantum event, such as the decay of a single radioactive atom. Every time the atom decays, a lethal mechanism is triggered. Every time it does not, the physicist survives. In this scenario, the experiment is repeated over and over, potentially indefinitely. Classical thinking would suggest a grim conclusion. Eventually, the physicist would die. But from the perspective of the many worlds interpretation, every possible outcome occurs in a separate branch of reality. In some universes, the physicist dies. In others, they survive. Critically, the physicist can only ever experience the branches in which they survive. From the observer's subjective perspective, it would seem as if they are immortal, surviving repeated quantum life or death events indefinitely. This thought experiment demonstrates one of the strangest implications of many worlds. conscious experience may be confined to branches where the observer continues to exist. In other words, while other versions of the physicist perish in alternate realities, the conscious you will only perceive those branches where survival occurs. It's a disturbing but fascinating illustration of how quantum branching interacts with consciousness. The quantum suicide experiment also highlights the probabilistic nature of quantum events. In standard quantum mechanics, the decay of a particle is random, with a calculable probability. But in many worlds, the particle doesn't randomly decide. It splits reality, creating branches for every potential outcome. The survivor always finds themselves in the branch where they remain alive, while other branches, equally real, continue independently. The implications of this thought experiment are profound. If consciousness always follows the branch where survival occurs, it suggests a kind of subjective immortality. From your perspective, death never occurs, even though countless other versions of you die in parallel worlds. While this does not grant true immortality in an objective sense, it only applies to the observer's perception. It forces us to reconsider what it means to exist, die, or experience reality. The quantum suicide experiment also intersects with philosophical debates about identity and the self. If there are countless versions of you across an infinite number of branches, which one is truly you? Are all versions equally real, or is consciousness confined to one subjective thread through the multiverse? This challenges our most basic assumptions about individuality, mortality, and the continuity of experience. Importantly, this thought experiment is not meant to be physically performed. It is purely theoretical. The ethical and practical consequences are obvious. No one should ever risk actual life and death experiments. Its purpose is to illustrate the extreme consequences of quantum branching and to explore the connection between quantum mechanics and consciousness. The quantum suicide experiment also complements other quantum paradoxes, like Schrödinger's cat. In both cases, the observer's fate is tied to a quantum event, yet the outcome depends on the branch of reality. Schrödinger's cat exists as alive and dead in separate branches. The physicist in the quantum suicide experiment exists only in branches where survival occurs. Both thought experiments highlight the counterintuitive nature of quantum superposition and many worlds. Some interpretations even suggest that the experiment could shed light on why we perceive a classical, stable reality despite the probabilistic nature of quantum mechanics. The observer naturally experiences only the branch where events continue coherently, which could explain why the world seems definite and predictable from our perspective, even if infinite possibilities exist simultaneously. Beyond physics, the quantum suicide experiment resonates with philosophical and existential questions. If our conscious experience is linked only to certain branches, could this principle apply to other life or death decisions, moments of chance, or even pivotal choices in daily life? It suggests a multiverse teeming with countless US, each following a path shaped by probabilities and quantum events, some surviving, some perishing, yet all equally real in their own worlds. While we cannot test this experimentally, the thought experiment encourages us to rethink mortality, probability, and the nature of reality itself. It provides a dramatic illustration of the staggering implications of many worlds in superposition, revealing a universe where consciousness and quantum branching are intimately connected, and where survival is a subjective experience spread across infinite realities. The quantum suicide experiment forces us to confront the strangeness and beauty of a multiverse. It asks us to imagine a reality far more complex than our everyday perception, a cosmos where every quantum possibility gives rise to a new branch of existence, and where the experience of life itself is intertwined with the infinite branches of the universe. In this realm, reality is not a single path but a vast network of possibilities, and consciousness is the thread that moves through it, perceiving only the outcomes where existence continues. The thought experiment may be unsettling, but it is also deeply illuminating. It shows that in the quantum multiverse, Life and death, probability and possibility, are not simple absolutes. They are part of an intricate, branching tapestry of realities, where every choice, every event, and every observer participates in an infinite cosmic dance. When people hear phrases like parallel realities or multiple worlds, they often imagine science fiction, alternate universes where history changed, where different versions of us live completely different lives. But what if the idea of parallel realities isn't just a far-off quantum concept? What if it subtly shapes the way we experience everyday life, decision-making, memory, and even chance? No, this doesn't mean people jump between universes or that we can somehow access other versions of ourselves. But quantum physics and the many worlds interpretation offer a framework for understanding how every moment of choice and uncertainty might be connected to a branching multiverse. The question is, how does this change the way we see our own lives? Let's start with the most familiar human experience: choices. Every day, from the smallest decision, like choosing what to eat for breakfast, to the biggest, like deciding on a career or moving to a new place, we walk down one path instead of another. In classical life, we often wonder, what if I had chosen differently? Those alternate choices live only in imagination. But in the many worlds interpretation, every possible decision branches into a separate universe where another version of you makes the opposite choice. This doesn't mean we can feel those alternate versions or interact with them. But it does give us a dramatic way to understand something very real. Every choice shapes the direction of our life. Thinking in parallel realities can be motivating. It reminds us that every small decision can shape a different future for the version of ourselves we become. Another everyday experience where parallel reality thinking often appears is déjà vu. People sometimes describe déjà vu as a moment where the world feels familiar in a strange way, like you've lived it before. Now, science explains this mostly through memory processes, neural timing, or brain pattern recognition, not multiverse glitches. But many worlds thinking gives people a poetic metaphor. What if déjà vu feels like a moment where the world resembles something a parallel version of you has experienced? Of course, this isn't literal physics, but it illustrates how humans naturally reach for multiverse-like frameworks to make sense of odd moments in consciousness. Quantum theories don't claim déjà vu comes from other realities, but they do show that the idea of parallel worlds is strangely intuitive to the human mind. Let's zoom in further to probability, something we experience constantly. Every time you flip a coin, roll a die, or take a test, there's uncertainty involved. In everyday thinking, only one result happens. But in the many worlds interpretation, all possible results occur, just in separate branches. You only experience one outcome, but that's simply the branch your version of consciousness follows. Does this change the way we live? For many people, it does. It encourages the idea that life is filled with possibilities, and that every moment contains multiple potential outcomes waiting to unfold. It can reshape how we see luck, chance, or missed opportunities. Instead of thinking, this was the only way things could go, many worlds thinking pushes us toward, this is just the way things went in this version of reality. Another everyday area where the idea of parallel realities shows up is memory. Human memory isn't like a video recorder, it's reconstructive. Every time we recall something, we rebuild the memory slightly differently. This is why memories shift, blur, or change over time. Some people relate this to the Mandela effect, where groups of people remember events differently. Science explains this through psychology, shared assumptions, and the way information spreads. But again, many worlds thinking gives people a colorful metaphor, multiple timelines overlapping in cultural memory. Even though there is no scientific evidence that memories come from alternate universes, the idea illustrates an important point. Our brains naturally create parallel versions of events all the time. We imagine alternate outcomes, fantasize about different futures, or rethink past scenarios. These mental parallel worlds help us plan, learn, and grow. Let's explore another dimension of everyday life: identity. In the multiverse picture, there isn't one fixed you. Instead, there are countless versions of you, each shaped by different choices and different circumstances. This doesn't diminish who you are. It emphasizes that identity is flexible, evolving, and deeply dependent on the direction you choose today. This way of thinking can help people break out of rigid self-labels like, "I've always been this way," or "I can't change." If parallel realities exist in physics, then multiple possible versions of you exist within your life as well, symbolically, through the choices you can still make. Quantum thinking inspires a growth mindset. You are not fixed, you are branching. Parallel realities also appear in creativity. Every time someone writes a story, creates a character, or imagines a different world, they are essentially building alternate realities in the mind. Many writers, artists, and filmmakers use the concept of parallel worlds to explore human nature, consequences, or alternative histories. These stories resonate because people intuitively understand that life is filled with what-ifs. Interestingly, modern technology has also started reflecting parallel world thinking. In video games, players often replay decisions, exploring alternate outcomes. In AI simulations or predictive models, algorithms explore thousands of possible scenarios before choosing the best one. Even social media shows people curated versions of lives, highlight reels that look like alternate versions of who they could be. Parallel realities show up in one more important place: hope. When life becomes difficult, people often look toward the future with a sense of multiple possibilities. The idea that things can change isn't just optimism, it's parallel thinking. It reflects the belief that the future isn't fixed, that multiple paths exist, and that we can shape the version of reality we step into next. The many worlds interpretation doesn't claim we can jump universes, access alternate selves, or change the past. But it does give us a powerful metaphor for life. Every moment is filled with branching potential, and the reality we experience depends on the choices we make. In this way, parallel realities feel much closer to daily life than we might expect. Not because we physically reach them, but because our minds naturally explore them every time we imagine, decide, dream, or hope. If science hints at a multiverse filled with branching timelines and infinite possibilities, then philosophy asks the next big question. What does that mean for us? For our choices, our identity, our values, our understanding of reality? The idea of multiple worlds is not just a scientific theory. It is a profound philosophical challenge. It forces us to rethink who we are, what matters, and how we fit into a cosmos that may be far larger and stranger than we ever imagined. Let's begin with one of the oldest philosophical puzzles: free will. If every choice we make leads to a branching universe where another version of us chooses differently, then what does it actually mean to choose? In daily life, we feel that decisions define us. Choosing kindness over cruelty, courage over fear, effort over laziness. But in the many worlds interpretation, every possible choice occurs somewhere. So does this weaken the meaning of choice? Many philosophers say no. In the universe you experience, you truly made your choice. The existence of other branches doesn't cancel the reality of your decision. It simply means the universe is richer and more complex than a single timeline. Others argue that many worlds strengthens free will because it means choice isn't predetermined. Every decision opens new paths, new futures, new versions of your story. Another deep philosophical question raised by the multiverse is about identity. If there are countless versions of you, some similar, some wildly different, then what makes you you? Are you defined by your specific memories, your personality, your physical body, or are you defined by the path you are currently experiencing among infinite possible yous? Many philosophers suggest that identity in a multiverse is not singular but relational. You are one version among many, a single thread woven into a vast cosmic fabric. This doesn't make your life less meaningful. It highlights that identity is shaped by choices, environment, and chance. You are unique because you walk your own path, even if parallel versions walk others. Then comes a question that has puzzled thinkers for centuries. Is the universe fine-tuned for life? Many cosmologists notice that the laws of physics are amazingly precise. Gravity, electromagnetism, and particle masses fall into perfect ranges for stars, planets, and chemistry to even exist. If they were different by the tiniest margin, life wouldn't be possible. The multiverse offers one philosophical interpretation. Perhaps ours is simply one universe among many, and we happen to live in a world where conditions allow life because only such worlds can produce observers like us. This is known as the anthropic principle. It shifts the question from why is the universe perfectly designed to, in an infinite set of universes, it is inevitable that some will support life. Some philosophers find comfort in this idea. Others feel it makes the universe seem less special. But either way, the multiverse changes the conversation about existence, purpose, and rarity. Another major philosophical implication involves morality. If infinite versions of events occur, does that affect the meaning of right and wrong? Most philosophers argue that morality remains grounded in the experience of this universe. Even if other branches exist, your actions here still shape real people, real consequences, and real futures. The existence of alternate universes doesn't dilute moral responsibility. It highlights that the version of reality you inhabit is shaped by your decisions. Yet the multiverse also invites compassion. If reality is branching constantly, if life is filled with possibilities, then judging someone based on a single action or mistake becomes less meaningful. People can change paths. Lives can shift direction. The universe, even in the many worlds view, is a space where growth and transformation matter deeply. One of the most profound philosophical impacts of multiverse thinking relates to meaning and significance. Some people fear that if the universe contains infinite realities, then individual lives might feel smaller, like tiny sparks in an endless cosmic sea. But others take the opposite view. A multiverse makes existence even more extraordinary. It suggests that life is not a rare accident but one expression of creativity in an endless cosmic landscape. In a multiverse, meaning doesn't come from being the only universe. It comes from being part of something unimaginably vast. Your life still has meaning because you experience it, shape it, and fill it with purpose. The existence of countless other worlds doesn't erase the value of this one. It highlights that reality is richer than we ever thought. Another major philosophical question concerns knowledge. If infinite universes exist, can we ever truly know which version of reality we're in? Can we ever gather evidence of other worlds? Some philosophers argue that if parallel universes are forever beyond our reach, then the concept becomes more metaphysical than scientific. Others see the multiverse as a natural extension of quantum math, a model that explains probabilities, fine-tuning, and cosmic structure. This raises a final question. What is the nature of truth in a multiverse? If reality contains infinite variations, does truth become relative? Most philosophers would say no. Truth still applies within a given universe, based on evidence and observation. The multiverse doesn't eliminate truth. It expands the domain of what is possible. The philosophical implications of multiple worlds can be both dizzying and inspiring. They challenge our assumptions about freedom, identity, morality, and meaning. They invite us to imagine a universe not limited to one timeline or one possibility, but filled with countless paths, each meaningful in its own right. The multiverse doesn't make life smaller. It makes it grander. It reminds us that existence, whether in one universe or many, is full of mystery, depth, and endless potential. And in the version of reality you are experiencing right now, your choices, your actions, and your story still matter profoundly. Parallel worlds have captured human imagination long before quantum physics gave us any scientific language to describe them. While the formal theories, from superposition to the many worlds interpretation, might seem abstract or inaccessible, popular culture has made these ideas feel dramatic, emotional, and sometimes eerily relatable. Movies, television, books, and games have become the playground where the multiverse becomes tangible, visual, and deeply human. In fact, for many people, fiction was their first introduction to the concept of the multiverse, long before they learned anything about quantum mechanics. Through storytelling, parallel realities transformed from a scientific curiosity into a powerful lens for exploring identity, choice, regret, hope, and the endless what-ifs that shape human life. The multiverse in film, cinema's grandest playground. Modern cinema has embraced the idea of infinite worlds with unmatched enthusiasm. One of the most influential portrayals comes from Everything Everywhere All at Once, which presents the multiverse not as a distant concept but as something chaotic, emotional, and shockingly personal. The film uses infinite realities to explore the human experience, how tiny decisions can bend the trajectory of one's life, and how every path not taken creates a new branch of possibility. Marvel's cinematic universe also mainstreamed the multiverse for a global audience. Films like Spider-Man, Into the Spider-Verse, and Doctor Strange in the Multiverse of Madness depict parallel versions of familiar characters, some heroic, some tragic, each shaped by slightly different past events. These stories suggest that identity is not fixed but fluid, something that can shift dramatically based on environment, relationships, and chance. Even earlier films such as The Matrix and Inception introduced audiences to alternative forms of reality, simulated, layered, or hidden behind consciousness. Though not literal multiverse stories, they tap into the same unsettling, fascinating question. What is real, and how would we know? Television, bringing parallel worlds into everyday life. TV shows, with their longer format, have explored parallel worlds with even greater depth. Series like Stranger Things popularized the idea of a hidden world overlapping our own, a shadow reality with its own rules and dangers. The Upside Down isn't just a sci-fi monster realm. It mirrors quantum ideas of unseen layers of existence. Rick and Morty takes the multiverse to comedic extremes, portraying countless versions of the same characters and universes ranging from bizarre to nightmarish. In its exaggerated chaos, the show captures a core idea of the many worlds interpretation. If every possibility can happen, some universes will be unbelievably weird. Even classic shows like Fringe, Doctor Who, and Star Trek have repeatedly used parallel worlds to explore ethical dilemmas, alternate futures, and the consequences of choices. Television reminds us that the multiverse isn't just about worlds. It's about relationships, identity, and the fragility of reality. Books and literature, the original multiverse universes. Long before Hollywood visualized the multiverse, authors used it as a powerful narrative tool. Jorge Luis Borges, in his labyrinth-like stories, imagined infinite branching realities reflecting every possible outcome. Philip K. Dick pushed the boundaries of perception, creating characters who slip between timelines and question their own existence. Michael Crichton's timeline introduced readers to the idea of quantum travel between parallel histories. Perhaps one of the most beloved examples is C.S. Lewis's The Chronicles of Narnia, where magical doorways open onto alternate worlds with their own physical laws and mythologies. Contemporary authors like Blake Crouch, Dark Matter, and Ted Chiang, Anxiety is the Dizziness of Freedom, explore the emotional impact of parallel lives. how a single altered choice can create radically different identities. Literature uses the multiverse not just as spectacle but as a mirror, reflecting our deepest fears and hopes. Video games, the player as the multiverse creator. Video games take the idea of multiple realities one step further by making the player an active participant. Choices alter storylines, create branching timelines, or shift entire worlds. Games like The Legend of Zelda, Ocarina of Time, BioShock Infinite, and Life is Strange explore how different decisions generate different outcomes. Role-playing games, from Mass Effect to Detroit, Become Human allow players to feel the weight of alternate possibilities. In a sense, every save file and replay becomes its own universe. Video games uniquely capture the essence of the many worlds interpretation. Every choice creates a new path, and every path is real in its own way. Why we're obsessed with parallel worlds in stories. The multiverse resonates so deeply in popular culture because it reflects something very human. The yearning to know how life could have been different. The concept touches on universal experiences, wondering about opportunities missed, imagining better or worse versions of ourselves, questioning fate and free will, exploring identity beyond a single life trajectory. Parallel world stories create a safe, imaginative space to explore these possibilities without real-life consequences. They also capture a deep scientific curiosity. Humans have always looked at the stars and wondered, are we alone? Are there other worlds? The multiverse is the ultimate extension of that curiosity. Other worlds not light years away, but existing beside us, layered with our own. Blurring the line between fiction and theory. What makes the current era remarkable is that the border between science and storytelling is thinner than ever. Ideas once reserved for theoretical physicists are now mainstream. Fiction has become a window into scientific possibility, helping audiences visualize complex theories like superposition, entanglement, and cosmic inflation. Popular culture doesn't just reflect science, it inspires it. Many physicists today admit that early exposure to science fiction sparked their curiosity and pushed them to explore the real mechanisms of the universe. When pop culture embraces parallel worlds, it does more than entertain. It expands collective imagination. It invites people of all backgrounds to think bigger, question deeper, and wonder boldly about the nature of existence. A universe bigger than imagination. From comic books to cinema, from novels to video games, parallel worlds have woven themselves into modern storytelling. They remind us that reality is not fixed, that existence is stranger and more fluid than we once believed, and that every moment is charged with infinite possibility. Popular culture gives us a glimpse, a metaphorical one, into the multiverse. But the real universe, governed by quantum mechanics, might be even more astonishing. And if the many worlds interpretation is true, then every story we've ever imagined may already exist somewhere in another reality. If parallel realities truly exist, if every decision, every quantum event, every cosmic divergence creates new branches of existence, then one of the most thrilling questions we can ask is this: could we ever travel between them? Could a person one day step out of this world and into another version of reality, one shaped by different choices, different histories, and different versions of ourselves? The idea of multiverse travel has fascinated science fiction for nearly a century. Yet beneath the imagination lies a deeper scientific question. Is such a journey even remotely possible according to physics as we understand it? Or is world hopping destined to remain purely metaphorical? The truth is complicated. On one hand, quantum mechanics suggests parallel worlds might be constantly forming. On the other, our physical reality appears sealed shut, with no known doorway to escape into alternate branches. Still, the possibilities, scientific, theoretical, and imaginative, are worth exploring. The barriers, Why multiverse travel seems impossible. The first obstacle is that parallel worlds aren't located somewhere in physical space. They don't sit beside one another like neighboring galaxies. According to the many worlds interpretation, other realities branch off mathematically, not spatially. They exist in a higher dimensional configuration space, not in a place we can simply walk toward. To visualize this, imagine a book. Each page is a different world. But the characters on one page can't rip the paper and walk into another unless the author writes it that way. Physics is the author of our world, and so far, it hasn't given us a tool for page hopping. Another barrier is quantum decoherence. Keeps worlds from interacting. As soon as a quantum event branches reality, the new paths no longer influence each other. This separation is instant and irreversible. If decoherence is a sealed door, multiverse travel requires finding or creating the key. But no evidence so far suggests such a key exists. Quantum tunneling. A bridge or a barrier? Quantum tunneling is sometimes imagined as a possible bridge between realities. After all, particles routinely pass through barriers that seem impossible at a classical level. But tunneling only allows movement within our universe. It doesn't link separate worlds. It simply allows particles to cheat classical physics inside a single timeline. Still, the phenomenon reminds us that nature does not always obey common intuition. If particles can violate classical rules, could there be deeper layers of physics we haven't yet discovered? Layers that might allow interactions between worlds. Scientists don't rule it out, but no model today offers a concrete mechanism. Brain worlds, universes that might touch. In string theory and M theory, our universe could be a three-dimensional brain floating in a higher dimensional space called the bulk. Other universes, other brains, might exist parallel to ours like huge sheets drifting in a cosmic ocean. If two brains came close enough or even collided, energy might leak between them. In theory, this could create shared gravitational effects, cosmic anomalies, or even brief moments of contact between universes. Some physicists have suggested that the Big Bang itself might have been caused by a brain collision. If true, this would mean universes can interact on massive scales. But for conscious beings like us to move between brains, that would require technology and an understanding of physics that we are nowhere near developing. Still, brain cosmology keeps the possibility open, at least at a theoretical level. Wormholes, fiction's favorite gateway. Wormholes are shortcuts through spacetime predicted by general relativity. They could, in theory, connect two distant points of our universe. Some have speculated that if multiple universes exist in a larger spacetime structure, wormholes might also link different worlds. Scientists face multiple challenges here. Wormholes require exotic matter to stabilize them. They might collapse instantly upon formation. They might not connect to other universes at all. Yet wormholes remain one of the most compelling frameworks for imagining a multiverse bridge. If humanity ever achieved mastery over spacetime engineering, wormholes could become a theoretical gateway, not just across the universe, but across realities. Quantum computing and the simulation metaphor. Some thinkers propose that if the universe behaves like a quantum information system, then different branches of reality might be encoded within the same cosmic processor. In this view, parallel universes could share deep informational foundations, even if they don't physically interact. But interacting with them would require manipulating quantum states across decohered branches, accessing them without collapsing them, navigating a configuration space beyond physical dimensions. This remains wildly speculative. Quantum computers today are nowhere near capable of such feats. Still, they hint at a future where information itself becomes the key to understanding parallel worlds. The human imagination, a pathway of its own. Even if physical travel remains impossible, Storytelling lets us travel across realities every day. Through imagination, humans explore versions of themselves, rewrite their pasts, and envision alternate futures. In this sense, multiverse travel already happens, but in the mind, not the laboratory. Stories of parallel worlds reflect a deeper psychological truth. People constantly compare the life they live with the lives they might have lived. The multiverse becomes a metaphor for human potential, regret, and the endless branching of possibility. Could future physics change everything? Many breakthroughs in science once seemed impossible. Flight, electricity, quantum mechanics itself. The limitations of today's knowledge are not the limitations of tomorrow's. If future physicists uncover deeper layers of reality, hidden dimensions, new particles, or unified theories, multiverse travel could shift from fantasy to remote possibility. But for now, parallel worlds remain sealed, isolated, unbridgeable. The final word, wonder, not access. Based on what we know today, traveling between parallel worlds is not possible. Quantum mechanics provides no mechanism. Cosmology offers no proven pathway. And energy requirements would likely be beyond anything humanity could ever generate. Yet the idea remains important, not because it's practical, but because it expands our sense of what reality could be. The universe is far stranger than we can imagine, and the multiverse, even if it remains out of reach, pushes us to stretch the boundaries of science, philosophy, and human curiosity. In the end, the impossibility of travel does not diminish the wonder. The existence of other worlds, if they are truly out there, reminds us that reality is richer, deeper, and more mysterious than any single lifetime can grasp. After exploring the mysteries of quantum mechanics, superposition, the many worlds interpretation, cosmic multiverses, and the philosophical questions they raise, we're left standing at the edge of something astonishing. The possibility that reality is far bigger, stranger, and more layered than anything we experience in daily life. If parallel worlds exist, even if we never visit them, then every moment we live is part of a vast structure of branching possibilities. Each decision, each action, each tiny fluctuation in the quantum world might create new versions of reality. Somewhere, another you may be living a different life, shaped by different choices and outcomes. And somewhere else, the universe itself may be built on unfamiliar laws, unfamiliar matter, and unfamiliar destinies. But beyond the science, multiverse theories offer something deeply human: perspective. They remind us that reality is not limited to what we can touch or see. They encourage us to think beyond the boundaries of our own experience and consider how vast existence might truly be. Whether the multiverse is infinite or illusionary, whether Everett was right or wrong, whether quantum events truly split reality or simply reflect hidden variables, one thing is certain: the universe is not a simple place. It is layered with mystery, complexity, and possibilities that challenge our imagination. And perhaps that is the real gift of parallel worlds. Not the scientific equations, but the reminder that life itself is full of potential. We may never walk through a portal into another universe, but every choice we make shapes the world we live in right now. So as we leave this journey, remember, reality is more extraordinary than it appears, and the greatest discoveries may still lie ahead, waiting in the unseen spaces between what we know and what we dream.